Okay, so can everybody see the AEW, the worksheet?
Yeah.
Okay, so I'm going to look at these in different ways. One way is when x is going to infinity, and you've got a polynomial divided by a polynomial. Basically, if x is going to infinity, then the 5x squared term is going to be basically controlling the top. Because if you have like a million squared times 5, it's going to be a huge number. And the minus 25 doesn't even matter that much. So you could approximate it by going the limit as x goes to infinity. So on the top, it's going to be 5x squared. And the bottom is basically controlled by the 125x cubed. And then I could reduce that. And let's see, a 5 will divide into a 125. So that will go 5 times on the bottom. And then x squared will cancel x squared. So it's going to leave just a 1 on top and then just x on the bottom. So this becomes basically 1 divided by infinity and 1 divided into an infinite number of pieces. Each piece will be so small, it goes to 0. So the answer should be 0. Anybody have any questions so far? Okay, so that is a way to approximate it. The approximation works most of the time. Then the way to really show your work is you look at all of the terms and you pick out whichever one is most powerful. And out of all the terms, the x cubed is the most powerful. So then you go the limit as x goes to infinity. So you take that x cubed and you divide every term by it. So on the top, 5x squared gets divided by x cubed. 25 gets divided by x cubed. 125x cubed gets divided by x cubed. And then the 150 gets divided by x cubed. And then as far as algebra, I could have these x cubes cancel right there. And then this x squared will cancel, so it just leaves 5 over x. So on the top, there's 5 over x minus 25 over x cubed can't be reduced. And then a 125 minus 150 over x cubed. So this is the way you're supposed to do it when you're supposed to show all of your work. And then you look at each term like the 5 divided by x. Well, if you take a 5 and divide it by infinity, the result is so small, it goes to 0. So this one goes to 0. The same thing happens with the 25 divided by x cubed. So that goes to 0. And this one also goes to 0. So that means all that's left is a 0 minus 0 on top. So that's 0. And on bottom, what's left is a 125 minus 0. So 125, 0 divided by 125 is 0. So we get the same answer. But doing it in 2 different ways. All right, moving on to part B. You know what I should do for part B? Anybody got any suggestions?
Factor the denominator.
So factoring is usually a good idea, but with x squared minus 1, you could factor that x plus 1 times x minus 1. But x squared plus 1, it can't be factored. It's actually prime.
Would it be better to just plug in the 1?
That's right. So whenever you can just plug in the number and get something that is defined, that's all you have to do. So if there was division by 0, you definitely would have to do something else. But if you plug in the number and you get something that is an actual number, like this is 0 divided by 2 equals 0, then that's the answer. Okay, now I'm going to go on to part C, but I want to do part C where I've got some more space. So with this one way to do it is use algebra. So that right now this is a complex fraction and the least common denominator is 2x. So then multiply on the top by 2x and multiply on the bottom by 2x. So when you distribute the 2x to the first term, the x's are going to cancel. It's only going to leave a 2. And when you distribute the 2x to the second one, the 2 on the top and the 2 on the bottom will cancel, so it'll leave minus x. And then for the bottom, just copy it down exactly as it was, x minus 2 times a 2x. So next, I want to cancel the x minus 2, but the two purple ones are not the same. So what do I have to do to get them to be the same?
Factor out a negative.
Yes. So on the top, you could factor out a negative 1. And then the x would become positive and the 2 would become negative. Then just copy down the bottom part again. And now that it's x minus 2 and x minus 2, those two can cancel. And after that, there's no more division by 0. So when you plug in the 2 for that 2x, then it's going to leave negative 1/4. So that's the traditional way to do it. That's how you do it at the beginning of the semester before we even had derivatives. But there is another way to do it. So go back to the original problem. And this thing right here, that's actually the definition of the derivative. The function is 1 over x. And then find the derivative. Does anybody know the derivative for 1 over x?
Negative 1 over x squared.
That's right. So that's one of those that you could do the power rule. You'd have to rewrite it like this. And then you go through the 3 steps of the power rule and simplifying it, and you'd end up with negative 1 over x squared. And then this part is saying that x is becoming a 2. So plug in a 2. And then we get negative 1 over 4. So it's the same answer as last time. Now I'm going to do it a third way. And this is something that all throughout math, it's one of my favorite things about math, is that you can do things in completely different ways, and yet you still end up with the same answer. Okay, so now something that we haven't covered before. And it's called L'Hopital's rule. And L'Hopital's rule goes like this. If you're taking a limit as x goes to whatever, let's say as x goes to a, and then you have a top and a bottom. And then you just plug in the number a, and then suppose that you get 0 divided by 0, or you get infinity divided by infinity, both of which are undefined. So if you get either of those, then what you do is you just take the derivative on the top and you take the derivative on the bottom. So not even the quotient rule, just take the derivative of the top and take the derivative of the bottom, and then you will get the same answer as the original problem. Okay, so then when you use L'Hopital's rule, you should either write down that the whole thing, I'm using L'Hopital's rule, or I just put the abbreviation. Okay, so then it's going to be the limit as x approaches 2. On the top, take the derivative. So the derivative of 1 over x is negative 1 over x squared. The derivative of negative 1/2, that's going to be 0. On the bottom, the derivative of x is just a 1. And then the derivative of negative 2 is 0. And then plug in the number 2, and we get the same answer. But L'Hopital's was probably the fastest and easiest out of the 3 methods. For some reason, they don't cover L'Hopital's rule until like the end of chapter 3. And I really wish they would cover it earlier because it really comes in handy. So does anyone have any questions on that one? Okay, then back to the top of the page. So for D, if you have pi divided by 0, that is undefined. And for this one, you could not use L'Hopital's rule because you can only use L'Hopital's rule if it's 0 divided by 0 or it's infinity divided by infinity. So L'Hopital's rule is not going to work. At least not on this one. Now this part right here doesn't actually say x is equal to 0. It's saying that it's getting closer and closer and closer to 0. So what happens to the pi over x if x is getting closer to 0? So if it's pi divided by a really small number. So if it's pi divided by a really small number, it turns out that it's like 3,000 and something. And then if it's pi divided by an even smaller number, now it's 314,000 and something. And then one more pi divided by something really small. And now it's like in the billions. So that means that it's going to infinity. So if you were to look at the sine graph, and this part is going to infinity, so it's basically becoming, what's sine of infinity? Well, for one cycle, the sine graph looks like this. But if you're supposed to go out to infinity, that means that you have to keep following the sine graph. Whoops. And it will just keep going up and down and up and down and up and down between +1 and -1, which means that this one does not have a solution. Or the limit does not exist. So in order for a limit to exist, it has to have just one solution, and this does not have just one solution. So what if I change the problem just slightly and I made it sine of x divided by x as x goes to infinity?
You could use the Lopi rule.
The L'Hopital's rule? So on the top, what's the derivative of sine?
Cosine.
It is cosine. And what's the derivative of x? It's just a 1. And then this would say, well, look at the cosine graph as x goes to infinity. Well, the cosine graph starts at the top and then goes down and then back up and then down and back up and down, down, down. So it seems like it's the same thing. It has no answer or no solution. So then what I'm going to do is I'm going to graph the function sine of x divided by x and see if it looks right. Is there no solution as you follow it off to the right? So y equals sine x divided by x. And then look at the graph. Let me make sure it's in radians. Oh yeah, it's in radians. So then if you look at the graph and if you follow it to the right, it's getting smaller and smaller and smaller and smaller. And if you look at the numbers, the Y value right now is 0.052. And if I go farther out to the right, it's now negative 0.064 and 0.097. So it seems that the answer is getting smaller and smaller and smaller, and it's actually going to 0. So that means that this part was not right, which means that this part was not right. And the reason it didn't work is because for L'Hopital's rule, it has to be 0 over 0 or infinity over infinity before you could use L'Hopital's rule. Well, with this one, sine of x over x, the bottom is going to infinity. And the very biggest that sine gets is 1. So it's not infinity divided by infinity. So with that one, you can't use L'Hopital's rule when it's sine of x over x. Okay, so that was extra stuff. Now back to the regular one. How about part E? Could we use L'Hopital's rule on that one? What happens if you plug in a 1? So if you plug in a 1, it would be 1 squared minus 1, 1 cubed minus 1, which means that it gives you 0 divided by 0. So for this one, we could use L'Hopital's rule. And on the top, the derivative of t squared will be 2t. And on the bottom, the derivative, and of course, the derivative of the negative 1s, that's going to be 0. And on the bottom, the derivative is 3t squared. And now you could plug in the 1, and it would just be 2 times 1 on the top and 3 times 1 squared on the bottom. So the answer would be 2/3. Now with part F. So I could do the approximation method when x is going to infinity, and you use the most powerful term and the most powerful term. So on top, that would be 3x cubed, and on the bottom, 6x squared. And then when I reduce that, it's going to leave just an x on the top and a 2 on the bottom. Which means it's going to be infinity divided by 2. Do y'all know what infinity is when you divide it by 2?
Would it just be infinity?
It would be infinity. So at the beginning, if you were to plug in infinity, this would be infinity plus, the top would be infinity plus 7. So the top would be infinity. And the bottom would be infinity plus 9. So the bottom would be infinity. So that means that for this one, you could also use L'Hopital's rule. And I do want to do it that way because something else I want to show you with L'Hopital's rule. So using L'Hopital's rule, this equals the limit as x goes to infinity. And then take the derivative on the top. So first there would be 3 times 3, so that's going to be 9x squared. And then for 6x squared, its derivative will be 12x. And the derivative of 7 is 0. And then on the bottom, this would be 12x plus 7. And x is still going to infinity, which means this would be infinity plus infinity on the top, so that equals infinity. On the bottom, it would be infinity plus 7, which is still infinity divided by infinity. And that's the reason I wanted to do this one with L'Hopital's rule, because sometimes you have to use L'Hopital's rule several times in a row. Basically, what it did is it took a more complicated problem and it made it simpler. But now we'll use L'Hopital's rule a second time to make it even simpler. So on the top, the derivative of 9x squared will be 18x. The derivative of 12x will be 12. And on the bottom, the derivative of 12x is 12, and the derivative of 7 is 0. So then L'Hopital's rule made it even simpler. So now that the bottom no longer has an x, it's no longer division by infinity, it's just division by 12. And then this would be infinity on top divided by 12. And if you divide infinity by 12, it's so big that it still equals infinity. Okay, on to number 2. So for this one, to find the derivative, we need to use the product rule. So take the derivative of the purple one, which will be 2 times x plus 2, and now it's to the 1 power. And then leave the x minus 3 cubed alone. Then the product rule goes plus, just copy down the purple one, x plus 2 is squared. And now take the derivative of the x minus 3 cubed. So that'll be 3 times x minus 3 is squared. And then set it equal to 0. In order to solve for x, I need to factor. So in green, there's x minus 3 cubed and there's x minus 3 squared. That means I could factor out the smaller amount. I can factor out x minus 3 squared. And then in purple, there's x plus 2 here, and there's also x plus 2 here. So that means that I could factor out an x plus 2. And then what's left? Well, there's the 2, and there's an x minus 3 that, a single x minus 3 that didn't get factored out. So there's a 2, and there's an x minus 3. And then plus, there's the number 3, and only one of the x plus 2's got canceled out. So there's 3 times x plus 2. And now that it's factored, you can set each factor equal to 0. So x minus 3 squared will equal 0. Another possibility is x plus 2 equals 0. And then for the last one, I need to go ahead and multiply or distribute the 2 over here and distribute the 3 over here. So this one would have 2x minus 6 plus 3x plus 6 equals 0. So for this first one from the x minus 3, the answer is going to be 3. For this middle one, the answer is going to be x equals negative 2. And over here, the negative 6 and positive 6 will actually cancel each other out. So that would just leave 5x equals 0, which means that x equals 0 is going to be the third answer. And then I'm going to graph it and see if these answers look correct. So when you graph, always graph the original function, not the derivative. So graph the original function, which was parentheses x plus 2, that gets squared, and x minus 3, that was raised to the third. Oh, it looks like I need to change the window. So go from negative 10 to 10, negative 10 to 10. So does it look right? So one answer was negative 2. That is correct. Since that's the top of the hill or a maximum value, then the derivative would equal 0 right there. So that one's correct. Another answer was 0, which is this one down here. And then that's a minimum value, so the derivative would equal 0. So that's correct. And then one other answer was x equals 3, which is right here. Can't seem to land right on the 3. All right, close enough, 2.999. And right there, the derivative also equals 0. So for this one, as it goes through 3, okay, there we go, right on 3. As it goes through 3, it goes horizontal just for a moment. And horizontal means that the slope is 0. So that is correct. So it looks like all 3 of the answers are correct. Does anybody have any questions? All right, then to number 3. When does the derivative equal 0? And when does the second derivative equal 0? So for the first derivative, that would be 15x squared minus 14x plus 8 and the derivative of +2 is a 0. And then set that equal to 0. And with a 15, a 4, and an 8, I don't think I could factor anything out. No. So it's possible that it could factor, but factoring only works sometimes. The quadratic formula works every time. So I'm going to use quadratic formula. So negative b, so negative of negative 14, plus or minus the square root. Negative 14 gets squared, minus 4 times 15 times 8. And then the whole thing is divided 2 times 15. So then I just did what's inside the radical. So negative 14 squared minus 4 times 15 times 8. And it gave me a negative 284. And the square root of a negative is an imaginary number. It is possible to do calculus with imaginary numbers, but that would be after Math 3A, 3B, and 3C. Throughout Math 3A, 3B, and 3C, we don't use any imaginary numbers. Okay, so that was for the first derivative. Then what about the second derivative? So in other words, take the derivative of the derivative. So the derivative of 15x squared, that will be 30x. And the derivative of negative 14x will be negative 14. And the derivative of plus 8 is 0. And then this one does have a solution. You could just, I think I'll subtract 30x from both sides. And then divide by negative 30, and the negatives will cancel. So 14 over 30. Or if I reduce that, let's see, divide by 2, divide by 2. So 7/15. So then to the graphing calculator, y equals, and the original function was 5x cubed minus 7x squared plus 8x plus 2. So if you look at this function, there's no place where the derivative equals 0. There's no place where it goes horizontal. So here it's going up. And with this little cursor thing, it's nice because it has that purple line that looks just like a tangent line. And it's got positive slope, and it's still going up and up and up, and it keeps going up all the time. So we got that there's no solution for the first derivative equals 0, but for the second derivative, there was an answer. That was 7/15. So then if I type in 7/15. So something important is happening to the graph right there. Why is it not showing my picture? Aw. Okay, well, I'll just show you on the graph. So what's happening at that point is the left side is concave down and the right side is concave up. So this part in here, so the shape of this is called concave down, and then right at that 7/15 it changes, and then this part is called concave up. So usually when we're speaking English, this is called concave, and this is called convex. So that's how we say it in English. But in math, we don't say it that way. We call this one concave up, and instead of convex, we call this one concave down. And it's the second derivative that tells you the concavity. For concave up, the second derivative is positive. And for concave down, the second derivative is negative. And it's easy to remember because when it's concave up, it's like a smile, and it's because it has a positive attitude. And when it's concave down, then it looks like a frown because it has a negative attitude. Okay, so for number 4, where is the derivative positive? So that means that f of x is going up. And going up is the way that we say it in English, but in math, we say that it's increasing. So in other words, in general, it's going up like that. So the first thing to do is take the derivative, and that's going to be negative 3x squared for the first term, and then plus 10x for the middle term, and the derivative of negative x is negative 1. And again, it's probably not going to factor, so use the old quadratic formula. So negative 10 plus or minus the square root 10 squared minus 4 times the a, which is negative 3, and the c, which is negative 1, all divided by 2 times the a. So then how much is in the radical? Let's see, that would be 100 for 10 squared. And then 3 negatives in a row makes it negative 12. So that's going to be the square root of 84. And then I'm just going to put that in the calculator and get the 2 decimal answers. So that is negative 10 plus minus square root of 84 over negative 6. So negative 10 plus the square root of 84, and then parentheses, the whole thing gets divided by negative 6. And then redo the same thing, but change it to minus the square root. So a 0.139 and a 3.194. Point 139 and 3.194. And then we're almost done with this one. I just need to see where it's increasing. So graph the original problem. Negative x cubed plus 5x squared minus x plus 2. Negative x is cubed plus 5x squared minus an x plus a 2. So it looks like most of the time it's going down. So here it's going down, 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 down. Then somewhere about right here, the derivative equals 0. Then it goes up for a little while, and then it goes down. So one value was 0.139. So that's the place where it starts going up, and it goes up until it gets to 3.194. So it's only that little region where it's going up, where it's increasing. So then my final answer is between x is a 0.139 and x is a 3.194. So whenever you say where it's increasing or decreasing, then you give the interval for the x's. Does anybody have questions on that one? Find the first and second derivative, also a place where the derivative equals 0. And if you look at these two functions, I made them to look almost exactly the same. But what's the difference?
The one has 2x and the other one has 1x only.
So this one has a sign of x, but this one doesn't have that. So the difference is this one means take sine of x times sine of x. That means that we're going to be using the product rule. But with part A, it's saying you have sine of x, and then substituted into that is another sine of x. And that means when you have one function substituted into another function, then use the chain rule to find the derivative. So for the first one, so with the chain rule, you start on the outside and you take the derivative of sine. And that is cosine. But whatever's inside the parentheses, you just leave it alone for right now. That's just going to be sine of x. And then the chain rule says, now you take whatever's inside the parentheses and take the derivative of that. And then that one is done. That's the first derivative. For part B, you do the product rule. So you take the derivative of the first sign, which will be cosine, and then you leave the second one alone. So just copy down sine x. And then the product rule has plus. This time, leave the first sign alone and take the derivative of the second sign, which is cosine. And then this one could actually be simplified because it has sine times cosine and another sine times cosine. So that means there's two of them that are sine times cosine. Or you could call it two of them that's cosine times sine, same thing. Next, find one place where the derivative equals 0. Well, because this one on part A has been factored, you could just separate it out and say, when does the first factor equal 0? Or when does the second factor equal 0? So both of them are basically saying, when does the cosine function equal 0? So one place would be right here, and that would be pi over 2. So for this one, you could then say, if x equals pi over 2, then that's where the derivative equals 0. And I did say find just one answer, but I just want to show you real quick. So basically, I was saying if x equals pi over 2, then that's where the derivative equals 0. With this one on the left, I would have to say, okay, it's pi over 2, but that means the inside part equals pi over 2. So that means I would have to put sine of x equals pi over 2. And pi over 2 is approximately 1.57. And what's the very biggest that sine ever gets?
One.
1, which means that this one would have no solution. So we would get the one solution from x equals pi over 2. Now, when you set this other one, part B, when you set that equal to 0, well, 2 is never going to equal 0, but sine does equal 0. And also cosine could equal 0. So for sine to equal 0, look at the sine graph. And between 0 and 2 pi, there would already be 3 answers. There'd be 0 and pi and 2 pi. So then you could just pick one of those answers, like x equals 0. And cosine would be pi over 2. So on that one, I said to do the second derivative as well, but we only have 2 minutes. And I just want to go over this one real fast because there's an important point from this one that we use throughout the semester a lot. Because this one asks for 2 things. Where's the derivative equals 0? And where's the derivative does not exist or undefined? So to begin with, we would need to use the quotient rule. So you start on the top, the derivative of 2x is just going to be 2. And then you just copy down the bottom, x cubed minus 1, put parentheses. And then it goes minus, now leave the 2x alone and take the derivative of x cubed minus 1. And that will be 3x squared. And then the bottom, you just put it in parentheses and square it. Well, for the derivative to equal 0, that means the top equals 0. And for the derivative to not exist, well, that would mean that you're dividing by 0. So basically, this means the top equals 0, and this means the bottom equals 0. So then I could just separate that into 2 separate problems. When does the top equal 0? So I would go ahead and distribute this. So there would be 2x cubed minus 2. And then this would be 6x cubed, but minus, so minus 6x cubed. And then for that one, if you combine like terms, that's going to be negative 4x cubed. And then I could add 2 to the other side. And then divide both sides by negative 4. And then last, take the cube root, and it's actually reduced. It's negative 1/2. So what is negative 1/2 when you cube root it? So x would equal a negative 0.794. And then the last part, when the derivative does not exist, so that's when the bottom equals 0. So set the bottom equal to 0. And then you could take the square root of both sides. So that would just leave x cubed minus 1 equals 0. And then add the 1 to both sides. And then finally, when you take the cube root of 1 is 1. So there are the 2 solutions. Do we do the whole thing? Oh my gosh, 12:03, and we just finished. Perfect timing.